Everybody, this is our lesson on measurements and conversions. So by the end of this, you should be able to convert between units of given measurements. This may be a little bit of a longer video, and that's more so because I kind of have to write some things in this PowerPoint, so just kind of bear with me as I transition between clicking and using a pen, things like that. So first, let's go over the metric system, which you've heard of before. So in science, we need to make sure we measure things the same across the board. And the way that we do that is through what's called the metric system. So if you think about it, why is it necessary? Why should scientists all use the same system of measurement? And that's because you could have people working on the same concept, the same theory, hypothesis, whatever it is, around the world, but if their data is not measured the same way, it won't be consistent enough to be validating altogether. So the metric system has been revised to what's called the International System of Unit, or SI, which is what we currently use. And just like the metric system, I mean, it's very similar, other than like certain things are not considered SI units that were metric units. We're measuring on a base of 10. So like 10, 100, 1,000, so on and so forth. And we use prefixes to kind of tell us those multiples of 10. So for instance, kilo means 1,000 base units. Deci is 1/10 of a base unit. Centi is 1/100th of a base unit. Milli is 1/1000th. And these last three, I think you can think of like a decade, a century, and a millennium, because a decade is 10 years, a century is 100, and a millennium is 1,000. And those would be like your base unit is 1 year. So you can kind of like look at those similarly. And then here, let me just kind of X out of my picture really quick. You can see the prefixes here that you can look at. These prefixes up here at the top of the steps are bigger prefixes. The ones at the bottom are smaller prefixes. So now let's talk a little bit about converting between these units. So the first way is to look at the math behind it. So if you're going from a large unit to a smaller unit, you're going to multiply by however many powers of 10 you need to get. Every time you move a prefix, that's a power of 10. And one thing to look at here, or the reason we multiply, if you're going from a larger unit to a smaller unit, that means there should be a lot more smaller units in that larger unit, right? So we should have a larger numerical value for a smaller unit. So they should be opposite. Small unit means large numerical value. But these values are going to be equivalent. So 1 kilogram is equal to 1,000 grams. Grams are smaller, so they get a bigger number, but those values are actually equal. Then if you need to go from a small unit to a larger unit, you're going to divide by however many powers of 10 that you need. An easy way to do this, easier way, not that this is very difficult, but the way that I tend to show my students how to do this is moving the decimal. So when you go from a large unit to a small unit, and this little square here should be an arrow, sorry, you will move the decimal to the right however many prefixes you move. So if you move 3 prefixes, you're going to move the decimal 3 places to the right. And when you do that, the gaps that you see, if you see any gaps, like when you start moving it and then there's no more numbers, you fill those gaps in with zeros. Then when going from a small unit to a larger unit, you'll move your decimal however many prefixes to the left. Okay, so if you look here, this is just a picture of what they call it the ladder method. So let's say we wanted to go from kilo to base unit. Well, kilo is a bigger unit than base, so we're going large to small, and we're going 1, 2, 3 to the right. So we would move our decimal place 1, 2, 3 to the right. Okay. If we were at milli and wanted to go to base units, so we're going from small to large, we would be going 1, 2, 3 to the left. So now let's try an example here. And I did put, I added this, so you may want to add this to your copy of your guided notes. But this is the acronym or prefix starters for you. So like kilo, hecta, deca, base unit, deci, centi, milli. And this is here just to show you, in case you like moving the decimal, how you do that. So we have 2 examples here. We're going to convert 42 liters to milliliters and 532 centimeters to meters. So the first example, we're going liters to milliliters, which is a small unit, a large unit to a small unit. So let me switch to a pen. I'll just do this one in red. And so if we're going from large to small, we are moving our decimal which way? Okay, large to small, we're moving our decimal to the right. Okay. So when we do that, we've got our decimal, or we've got our number. When your number does not have a decimal in it, you just assume it's at the end. So I'm going to put a decimal at the end. And we are going liter, which is a base unit, to milliliter. So we're going to start at liter and go to milliliter. So we're going 1, 2, 3 to the right. So we're going to take that decimal and go 1, 2, 3 to the right. So you see there's nothing in these spaces here. Whoops. So we are going to put, and this is very sloppy, sorry, zeros there. So your final answer should come out to 42. I'm very sorry, this is sloppy. I'll get used to it hopefully by the end of this class. 42,000 milliliters. Okay, so that was that example. So now let's look at the information for the second one. So we're going centimeters to meters, which is small to large. So we're doing the opposite, which means we are moving to the left. Okay. And since we're moving to the left, we're going from centimeter right here to meter. So we are moving 1, 2 to the left. Remember, we're putting our little decimal there at the end since it wasn't in the number already. 1 to the left. So my answer is 5.32 meters. Okay, so when you look at this for a large to small unit, remember your number should look bigger, which it does, 42 versus 42,000, and vice versa for small to large. So we're going to a larger unit, my number should look smaller, which it does here. So now you need to pause the video really quick and try these 2 examples. Oh, let me clear off this screen. Okay. So now let's talk about types of measurements that we've got. So this part I'm going to try to go through as quickly as I can. It's a lot of information, but we're going to go through it quickly. So length is one type of measurement that we have, and we measure that in meters. That's our SI unit. And we usually will use a metric ruler or a meter stick. We don't like to use like a standard ruler because that's in feet, and that doesn't measure meters. So we will use meter sticks and metric rulers here. Our next one is volume, and volume measures the amount of space that an object takes up. So it's the amount of space something has. And liquid volume, which is what we normally will measure in the class, is measured in liters. And this is slightly larger than a quart, but you don't really need to worry too much about that conversion there. We tend to use beakers or graduated cylinders for this, and I will say you will want to deal with like this one is the more important one to know, is graduated cylinders. because they're much more accurate in the lab, so we use those more often. When using that graduated cylinder, though, you always read from what's called the meniscus, which is the curve of the liquid. So for water, it looks like this picture here. I know this is yellow, but it will curve down. So you always read from the bottom. So here, you don't want to say you have 22 milliliters of liquid. You actually have 20 milliliters of liquid. Oh. Let me clear this. I'm still learning how to use these tools. Sorry, guys. More measurements. So for volume, you can determine the volume of a solid, of an object, length times width times height. So you should remember this from math. And this is usually expressed in centimeters cubed or meters cubed. So you would your unit would look like this, one of those two, usually centimeters cubed. And I will add this in. You can do this for odd-shaped objects that are not where you can measure length, width, and height, but that comes with a whole different process that you have to do that we'll talk about later on in the class. Another measurement to know is mass, and we will measure this. Well, this is the amount of matter within a substance, what it's made up of, how much it's made up of. And the unit that we normally use is gram. The SI unit is kilogram, actually. But in the lab, we tend to use grams because we don't need that much of a sample. And then we'll use a triple beam balance to measure in this course. So you guys should have seen one of these before. That's what we'll use to measure mass. Time is another measurement that we'll look at. And this is just an interval between two events. It could be seconds, which is what we tend to use, minutes, days, years, all of those measure time. But again, the unit that we like to use is seconds. And we will use a stopwatch for this. I'm sorry, I have the hiccups. We will use a stopwatch for this because that we don't have to measure long amounts of time during this course. So. Now, the last one that we're looking at here is temperature, and this is a big one, so that's why I wanted to kind of get through the rest of this. So temperature is the measure of the average kinetic energy of all the particles in a sample of matter, how fast or how slow they are moving, because how fast or slow they're moving tells you how hot or cold an object is. The faster the particles are moving, the hotter that object is, because the more heat it has, the more those particles can move. So the colder an object is, the slower those particles are moving. And we'll use a thermometer just like you normally would use a thermometer for anything else. And there are 3 different scales that we look at in this course. 2 of them are ones that I like to focus on, and that's purely because if you go on to take chemistry, these are the 2 that you'll look at. So the first one is Kelvin. This is your SI unit for temperature, and your symbol is just a capital K. There is no degree sign here. Okay. One value to know, and this is more just for definition, is absolute zero, which is 0 Kelvin. This is the temperature at which all motion of particles theoretically stops. So like even electrons will stop moving. We've not gotten to this temperature yet. We've gotten very close, but not to absolute zero. Celsius is the other one that's very common, and you guys should have seen this one or heard this one before. So this is degrees Celsius for your symbol. This is on a 100-degree scale, so 0 to 100. And that's why I like using Kelvin as well, because it is also on a 100-degree scale, but it's from 273 to 373. So 273 is like 0 on Celsius. 373 is like 100 on Celsius. So you can see your points there. Then the last one is Fahrenheit. This is the one I deal the least with, especially as you move into like chemistry. But you guys know what Fahrenheit is, and you know the symbol there. Freezing point for water, and these are all from reference of water, is 32 degrees Fahrenheit. Boiling is 212. And there you go. Cute little meme or GIF there. So now let's look at all of the conversions that we have here that you need to know. So for Fahrenheit, if you're given Celsius, you're going to use this first calculation. If you're given Celsius or given Fahrenheit and you want to go to Celsius, you'll use the second calculation. And then, like I said, Kelvin is pretty easy. You just subtract or add 273. Okay. So here is just an example very quickly to show you how to plug these in. Okay. And now let's get on to our last example here. And this is doing some basic conversions. So we're going to convert from Fahrenheit to Celsius. So we need Celsius. And the next one is Celsius to Kelvin, so we'll come back to that. So let me get my little pen out. Well, actually, I don't think I need it just yet. There we go. All right, so if we look at this example, we've got our calculations 0.055 times Fahrenheit minus 32. Well, the Fahrenheit that was given is 38. Okay, so 0.055 times 38 minus 32. Well, 38 minus 32 is 6. So you're going to do 0.055 times 6. Which when you do that on your calculator, comes out to 3.3 degrees Celsius, which should make sense because if we're looking at 38 degrees Fahrenheit and 32 degrees is freezing, we are not far above freezing. Well, for Celsius, freezing was 0, and we're at 3.3, so we're not far above that either. Great. So now let's look at the next one, which is Celsius to Kelvin. Okay, so we've got Celsius. All we've got to do is add 273, which would be 37 times 273. I'm sorry, plus 273, which comes out to 310 Kelvin. No degree symbol. Okay. So those are very quick and easy. So now you can pause the video and you can try these two examples, which are in your notes. And now you guys should feel comfortable and be able to convert between units of different types of measurement.